Hey, how's it going? Mr. Hernandez here, and I'm going to be going over extraneous solutions. So, by now you've had exposure to solving for radical functions, where you want to isolate this radical here, this square root, by, let's say, moving over, the 1. And here we're just, solving normally. 0 minus 1 is -1. And then to get rid of a square root, you got to square it because they'll undo each other. But whatever you do to one side here, you got to do to the other. So now you're left with the radicand, or whatever's left under the square root. And -1 squared is +1. -1 times -1 is +1. And then the last step is adding 3. Now this is a solution. We solved it algebraically. It was done flawlessly, following every rule of algebra. But if you're checking for extraneous solutions, what you're doing is two things you could do. So one thing you could do is to plug the solution back into the original equation. That's one option. And another option is to graph. And so I'll go over the first one first. So if we plug this 4 into the original equation, we're going to get, let's see, so that's a negative, so it's going to be 1 plus the square root, and instead of x minus 3, since x equals 4, we're going to do 4 minus 3, and then equals 0. So if we now, instead of solving, we're just simplifying. Everything's just going to be carried down. The square root of 1 is 1. So now we just bring down 1 plus, bring down the equals, bring down the 0. 1 plus 1 is 2. 2 equals 4? No, that's false. So if you plug it back into the original equation and it doesn't make the equation true, that is an extraneous solution. Okay, so this here is an extraneous solution here. So the second method is graphing. Let me just change the color just so I can kind of change the. Let's see here. Okay, so when you're graphing equations, you will look for where they cross. So here's what I mean. If you solved, let's say, 2x plus 1 equals 5x minus 2, solving it, I mean, I'm going to do this real quick. So, subtract the 2. Wait, that doesn't cancel out. This one does. Subtract the 2. So that's 3x minus 2. Add 2, add 2. Now you have 3x equals 3 divided by the coefficient. And you get x equals 1. Okay, so graphically, though, you could graph this as a y equals. You could graph this as a y equals, and you can see where they cross. That's another name for solution. So where they intersect. So 2x plus 1. I graph that, or I could put y equals here. And then the other one was 5x minus 2. And I could see that they are going to cross right here at x equals 1. Notice that if you're solving for x, which is what we're doing here, notice there's only x variables here. If you're solving for x, the solution is the x coordinate where they cross, so it's 1. So you could pretty much do that for any equation. For any equation is when you graph both sides of an equation and you're looking for where they cross. Now if I graph this here, and so if I graph the original, y equals 1 plus that and y equals 0, let's see what happens. So let's see, y equals 1 plus the square root of x minus 3. X minus 3 is under the radical, so the x minus 3 is the radicand, and then y equals 0. Okay, so here you could see that the two lines don't cross. I mean, there's this imaginary kind of line right here, right? Like this. So this really kind of imagine going, if this was a, if it reflected down, it would actually cross right here. And that is actually at x equals 4, right? But it doesn't. So this part of the graph is not there. But if it were, it would cross at x equals 4. And that's what you found algebraically, but graphically, you see that it does not cross. So when there's no when there's no intersection, the solution is extraneous. So if you graph both sides of an equation and they don't cross or intersect, well, then you have an extraneous solution as well, which this is, right? Because these don't cross. So those are two different ways of checking for extraneous solution. Taking the answer, plugging it back in to see if it makes it true, or graphing both sides of an equation, y equals whatever this is, y equals whatever this side is, and seeing that they do not intersect. Okay, so those are the two, and I'll put a line here, those are the two methods of checking for extraneous solutions.